still a little bit of a review on algebra, but let's go ahead and get started. So first we're going to talk about translating verbal expressions and algebraic expressions. So in example 1, we have translate the verbal expression. So 3 times the difference of a number and 8, right? And what does the word difference mean? Subtraction. So it's 3 times the difference of a number and 8. And if you have difference, then whatever comes after must be left in the same order. So you have to keep the order. So it's x minus 8, right? You wouldn't do 8 minus x. You couldn't with subtraction. Next, I have the cube of a number increased by 4 times the same number. So the cube of a number, x cubed, and what's increased by?
4 times.
Plus 4 times the same number, right, 4x. I used to love these when I was in high school. Okay. Now can we go, thank you. Now can we go backwards and write this in words? Right, it's exactly the same thing, right? It's the cube of a number increased by, and you could say, add it to, or, or the sum of the cube of a number and 4 times the number, the same number. Okay, so what about this one? Now we have an equation, right? So 2 times a number, right? And we say equals, or what else could we say? Is, or is the same as, right? Any one of them will work. Equals the number the square of the number. You could say the number squared. So here we could do like a whole bunch of different things. We could say the square of the number subtracted by 4. You could say the difference between the square of a number and so on. Or decreased by. Let's do decreased by today. The square of the number. So if you say the number, like if you have a number before and then you say the number, then it's sort of understood that it's the same number, right? The number decreased by 4. Okay. All right, so here we have some properties of equality, and in geometry actually you go over this and then you pair them with the properties of congruence. The first is the reflexive property. Basically, it says anything is equal to itself, okay? Like 5 is equal to 5, and so on. That's the basic. So reflexive, okay? Symmetric is something like, for example, 3 plus x is equal to x plus 3. It's like the mirror image, okay? Transitive, you have to be comparing 3 items. Okay, so if let's say if John is the same age as Linda, and if Linda is the same age as Sam, then John and Sam are the same age, right? So you're comparing 3 things. And then substitution is when we replace something by something else. So this is the best example here. So here we have 6 plus 1 times x equals 21. Now what is 6 plus 1? 7. So I just replace that by 7. That's substitution, right? I've done nothing else other than replacing one item with an equivalent item. Okay? Yeah.
Do you prefer if it's like in that situation where the thing multiplies on the outside of the parentheses, like on the far right side? Do you like it on the far left?
Doesn't matter. Yeah, it doesn't matter. Okay, so which property is being used here? Okay, so what we do is we compare this with this. Which property is used? Yeah. Symmetric. Whoops. Symmetric because it's two different equations and then they're sort of like flipped, right? Okay. Addition and subtraction properties. Students sometimes confuse this. They think every time there is an addition sign, it's the addition property. No. It's the addition property if you've got an equation and you add the same number to both sides. So for example, if you have x minus 7 equals 2, how would I solve this?
You would
Add 7, add 7. You see how I did it twice? That's the addition property. Now, if I just have this, x plus 3 is equal to 2, like if you're just because there is a plus sign there, it doesn't mean that that's the addition property. There's no addition property happening here. Now, if I do minus 3, that's the subtraction property, right? So if you're adding the same thing to both sides, it could be adding x, it could be adding y, whatever. Multiplication and division properties are the same. You have to multiply both sides, times 3 times 3. Just because there is a multiplication symbol doesn't mean it's the multiplication property. Okay, so here we're going to solve and then we're going to say every single time what is being used. So plus 14.29 plus 14.29, right? What property is that? That's the addition property. You could say add property, yeah. And then, this is fine, add prop. And then what do we have here? X equals 39.29. Which property is that? Not multiplication. Substitution. Because what I did is, here, 25 plus 14, that's the same as 39.29. So I took this away and substituted this instead. So that's the substitution property. Just a piece of, some caution. If you're going to abbreviate, SUB means nothing. I don't know if it's subtraction or substitution, so make it clear. Okay, what about here? What are we going to multiply by? 3 over 2. And what property is that? Multiplication property. So y is negative 27, and that's substitution. Okay, here, what am I going to do first? Distribute. So negative 10x plus 12x minus 6 equals 6. This is the distributive property. I distributed the 3. And now I get 2x minus 6 equals 6. What did I do? Right? So what property is that? Okay, so that's the thing. So this is where it comes in. What is it? You want to change your mind? It is the substitution, right? It's substitution. It's not subtraction or addition because I didn't do plus this on both sides, right? This is where, like, honestly with this, that's where most of the confusion happens. Now, I'm going to do plus 6, right? That's addition. And then 2x is 12. X is 6. Right. So after this, I could just do x is, I'll let you like skip some steps. If you just do x is 6 and say division, I'm fine with that. Yeah. Starla, right?
Yeah.
Yeah.
Would it be a question on the test that we have to like identify every property on that?
Maybe. I'll have it very clear though, like it won't be ambiguous. And you know, things like this, I look at everybody, like everybody's work individually, right? So here, solve for H in this formula. And then it says note the property used for each step. So first, why don't we just solve and then we'll go in and write everything. So A is half H B1 plus B2. We're going to solve for H here. So what are we going to do first? Well, before that, I would multiply, right, both sides by 2. So I get 2A equals H B1 plus B2. And then what?
Divide both sides by B1.
No, you have to.
I'm going to do it later.
Distribute.
Well, okay, so this is the thing. If you're solving for H, I could just divide and do it, and save like 3 steps. Okay? Now, when I divide by B1 plus B2, right? Let me just write it like this. It'll be 2A over B1 plus B2 equal to H. Okay? So I divided by B1 plus B2. I divided by B1 plus B2. Okay? So let's write down the steps. So first it was what? Multiplication property, then division property, and then division property again. No, that's it, substitution. Okay? Okay. So that's that.
Oh, is that the final?
Yeah, that's it. We're done.
Oh, are we all seeing 1.4 today?
Yeah. Absolute value. Finally, some good stuff.
Yay!
Okay, yay. Okay, so absolute value. What is absolute value? Yeah.
Sorry, I like that. We went just between the lines.
Uh-huh.
If it's a negative, it becomes positive. The positive, it stays a positive.
Mm-hmm.
So lines pretty much mean anything positive.
Right. Correct. Anything that comes out of the absolute value is always positive. Yes?
It's the distance between 2 and 0.
Right. Right. So,
It's a distance, and distance can never be negative.
correct. So now, if I were to tell you I am standing at a spot 4 units away from 0, right? Where would I be? On the number line. I could be here, right? Is that 4 units away from 0? Is that the only place I could be? No, I could also be here, right? So, 4 units away from 0 puts me at 2 different places, here and here. So now another way to look at it is, if I'm here, what's my distance from 0? 4. If I'm here, what's my distance from 0? 4. So now, if I wanted to say the distance between 4 and 0, that's like a lot of writing. I could abbreviate that by this. Okay? Now, if I wanted to say the distance between -4 and 0, how could I abbreviate that? Absolute value -4, right? What does that give me? 4. What does that give me? 4. Does that make sense? Should those have the same distance from 0? Yeah. So that's what absolute value is. when you put anything inside absolute values, it means the distance between that and 0. Okay? So if I have this, it's the difference, but it's the distance between that number x and 0. Absolute value table, the distance between a table and 0. Okay? And it could be in any location. All right, so that's what absolute value really means. So if I were to ever see you like out on campus somewhere, and if I were to come and tap you on the shoulder and say, hey, what's absolute value? What are you going to tell you? What are you going to tell me? The distance between a number and 0. Okay? That's what it is. Now, let's evaluate. What did we say yesterday evaluate meant? Solve or find a number. Find a numerical answer. All right, that's what evaluate means. If x is equal to -2, so first we're going to put in -2 for x. So here, 4 times, what do I use with negatives always? Parentheses, plus 3 minus 3.5. This would probably be a good time to tell you I'm not a fan of mixed numbers. I have it here because the book sometimes uses mixed numbers. In the real world, it's all about improper fractions, right? But that's okay, we could deal with it. We're flexible. So here I have -8 plus 3, -5 in the absolute value minus 3.5. So what is that? Right, that's 5 minus 3.5. And if you put it in common denominators, it'll be 10/2 minus 7/2, which is 3/2, which is 1.5. So yeah, I did common denominator. Now you could also here at that step have said, okay, so 5 minus 3.5, you could have done it mentally, and we could also say it's 1.5, right? And 1.5 is 3/2. Any which way is fine, okay? Eventually, by June, that's what we will be doing. All right, so I'll give you about a minute to do that next one.
Is there only one answer for this one?
Yeah, yeah, later, yes. Do B, please. I'll give you a minute. Right, so the absolute value, so first we simplify everything in the absolute value, and that gives me a 5. Now, -2 times absolute value of 5, mentally I say, okay, that's -2 times 5, which is -10, plus 8 will give me a -2. Okay? Okay. Okay, what did absolute value mean again? The distance from, right, the distance between what's inside and 0. So here at the bottom, it's telling you that the distance between this and 0 is how much? It's 3, right? So that's what this is telling you. This is telling you the distance between x minus 5 and 0 is 3. That means if I were on a number line, so let's say it wasn't x minus 5, let's say it's a table in that absolute value. It would mean the distance between a table and 0 is 3. So if you're on the number line and this is 0, what are some possible places that that table could be? Where could it be? On the what? So the distance between this item and 0 is 3, right? So it's either here at 3, right, and the distance is 3, or it's at negative 3, and the distance is 3. Okay? Does that make sense? So this is telling you that there is a table, and the distance between the table and 0 is 3. So that table could be here, distance of 3, or it could be here, distance of 3.
Well, I thought it was telling the difference between x and -5.
No. So what we said was anything in the absolute value, the distance between that and 0 is 3. Okay? So now though, but we don't have a table. What we have there is x minus 5. So the x minus 5 is either at 3, or the x minus 5 is either at negative 3. Right. So there are two possibilities. That's the visual behind it. Mathematically, what do? We have to create two separate equations because we have to say, okay, this looks like x minus 5 could be equal to negative 3, or x minus 5 could be equal to positive 3. Right? So essentially, when you have absolute value equals a number, we say, okay, that equals positive this, and that equals negative this. That's all. Bottom line.
So you have to separate it.
Yes, we separate the two. Now we have two separate equations, and they're two separate like pre-algebra type equations. So we add 5, x is 2 on this side. We add 5. X is 8 on this side. So there are two possibilities for x. Okay? So now, let's do this. Let's solve the equation, right? And then we'll look at number line. So how are we going to solve this? X plus 3 equals to what?
6.
Right? And?
-6.
Right. Equal to negative 6 and positive 6. We subtract. X is negative 9. And go ahead and continue. I'll give you about a minute. Here we get x equals negative 9. And here we get x equals 3, right? And for this one, we had said x minus 7 equals negative 4, and x minus 7 is equal to positive 4. And what was x for the first case? For this one, it'll be 3. I'm sorry. X minus 7 is equal to 4, and here x is equal to 11. Okay, now what's the number line all about? The number line is central value and range on a number line. So basically what you do is, do you see this one, x plus 3? Okay. In math, when you have like plus inside with x, it usually means go to negative 3, right? So this means go left negative 3 units. So we go here, 1, 2, 3. Okay. And now, the distance is 6, right? The distance away from that dot is going to be 6. So I go 6 to the right, 1, 2, 3, 4, 5, 6, and 6 to the left, 1, 2, 3, 4, 5, 6. And look at that. What do I have? Where did I end up? At negative 9 and 3. Okay, at negative 9 and 3. So here, if it has x minus 7, which direction am I going to go? Opposite direction, this way, 7 units. Okay, and then I go up 4, 1, 2, 3, 4, that'll be at 11. And then down 4, 1, 2, 3, 4 at 3. Okay, yes.
So on a test, if we're doing a number line, you want to do the dot and the 2 lines?
Yes.
Not just the 2.
Right. We're going to be doing several number lines on this test. Okay, when do you get no solution? So what we hit on earlier was absolute value is the distance from 0. Can distance ever be negative? No. So you can never say absolute value equals a negative value. That's like you saying the distance between this and this is -3. That just doesn't make sense. That's silly. So take a look at this one. In order to solve something like this, I first have to isolate the absolute value. So divide both sides by -2. Whoops. And then I have absolute value of 3a equals -3. And that's just silly. That can't happen. Okay? Absolute value can't equal a negative. Cannot equal a negative number. So this is no solution. Okay? Okay. When an absolute value expression is set to an expression containing a variable, you may or may not encounter extraneous solutions. So take a look at what we do here. First, we want to isolate the absolute value. So I'm going to add x to both sides, and that'll be 2x plus 1 equals 4x minus 4. Now what are we going to do? Divide everything by 2. Divide everything by 2. So x plus 1, 2x minus 2. Guess what we do now? What did we do before? Split it into 2, and we're going to do the same thing. So we're going to do x plus 1 is equal to the negative of this, and x plus 1 is equal to the positive of that. Okay? So x plus 1 is equal to negative whatever that is. X plus 1 is equal to positive whatever that is. And now we solve like too many equations. So go ahead and solve this one.
Into the equation up above, it doesn't equal itself.
Okay, good. So let's see if they work. Okay, let's check our work. So first let's do x equals a third. We're going to plug it into that initial equation. So 2 times 1/3 plus 1 in the absolute value minus a third. And we're going to say, does this equal to, that's how I write it, does this equal to 3 times 1/3 minus 4? Okay? All right. This is 2 times. What's in the absolute value? It's a third and a 1. It's 1 and 1/3, which is 4/3. And that's positive, so it comes out of the absolute value. Minus 1/3. Is this equal to, now what am I going to get here? 3 times a third is 1 minus 4. -3. Okay, so here, 3 and a third, the 3's cancel. So I get 1 minus 3, minus 4 is -3. Okay, so let's see what I have here. 8/3 minus 1/3. Is this the same as -3?
No.
No, because I get 7/3 here. And that's not the same as -3. So that means this solution does not work. Hence the extraneous part. That's an extra solution that does not work. Now, does 3 work? They could both work. They could both not work, and it could be that one works and one doesn't. So if you plug in the 3, it'll be 2 times 3 plus 1 minus 3. Does that equal to 3 times 3 minus 4? So if we do that quickly, 2 times 4 minus 3, is that equal to 9 minus 4? What's that these days? A 5. So here I have 2 times 4, 8 minus 3, 5 equals 5. Oh my goodness, that does work. So the only answer here is x equals 3. Okay? All right, now, yes.
Are there any tips to knowing, I know teachers don't like hearing this, but are there any tips for recognizing the extraneous solution, especially if it's a long problem before checking it?
Not really. Yeah, not really. So for Wednesday, right, the homework is this from page 22 and this from page 30. So both of those. And what I want, hang on, Max, have a seat until I finish talking. Let's do it later. I want you to start each homework on a fresh page.